Thank you all for joining us for the California-Nevada Drought and Climate Outlook Webinar. I'm Julie Klansky. I'm at Scripps Institution of Oceanography, part of the CNAP group, the California-Nevada Climate Adaptations Program, and I'll be stepping in for Amanda Sheffield today, who's the NIDIS California-Nevada DEWS coordinator. She's on travel. So we have, I would say, a great lineup overall. So I will be doing the drought and climate update, but then after that, Nathan Patrick from the California Nevada River Forecast Center will be talking about the outlook. And as we generally do on our March webinars, give a rangeland update. So Leslie Roach of the UC Extension will be talking about California, and Patty Novick-Echenik will be talking about Nevada. So before I jump into the update, I'm going to provide a little bit of information about what NIDIS is for those of you that are new to these webinars. So NIDIS has the drought early warning systems that is broken up into various different regions throughout the US. Here we are obviously focused on the California-Nevada one. A drought early warning system utilizes new and existing network of federal, tribal, state, local, and academic partners to make climate and drought science accessible and useful for decision makers. And so there's really the 5 pillars of it: the planning and preparedness, observations and monitoring, interdisciplinary research and applications, prediction and forecasting. And then what we're doing here today is this communication and outreach, which the webinar is a part of. I just wanted to highlight that there are some new tools on drought.gov, and in particular, the current soil moisture conditions and flash drought agriculture and vegetation. And so we can put the link in the chat after I'm done presenting, so you can check these new tools on drought.gov out. So with that, I'm going to stop sharing this and start on the drought and climate update. So this is, as of last week, the US Drought Monitor, and as you can see throughout the region, there's almost no drought. So in California, there's just a little bit below 5% of abnormally dry conditions than some of the corner regions. Nevada has a higher percentage of that abnormally dry conditions, at almost 15%, and some moderate drought in that southeast corner in Clark County around Lake Mead. I want to start back a little bit in thinking about the water year, because at our last webinar in January, we were talking about what a slow start it was. And so this is just going back to January 5th. You can see the precipitation throughout California and Nevada being much below normal for that time of year. And this is focused on this year. Nevada's, but snowpack generally was for that time of year, it was pretty dismal, especially in the southern Sierras at about a third, a little over 50% in the central, and just about 2/3 in the northern. And then after that, so this is a map that the Center for Western Weather and Water Extremes put together that looks at landfalling atmospheric rivers. And this was just through about a month ago, looking at the atmospheric rivers. But a couple of things I want to highlight here is for our region, a lot of the moderate to strong ones came mostly after that January 5th or 25th webinar, where you see the extreme one. Although it may landfall on the Oregon coast, it came down along the coast and produced quite a bit of precipitation. We have a lot of February ones throughout the southern coast. And so it was really this slow start, but then some of these atmospheric rivers and other storm types really help to mitigate some of that kind of missing precipitation or below normal. And so this was just as of February. You can see a lot of that below normal precipitation was near normal, especially in the northern parts of the region and along the coast, but the Sierras were still missing quite a bit of precipitation. So you can still see here, it was at although the coast, like I said, the coast and northern regions got a fair bit of precipitation from those storms, the Sierras less so. Since then, we've seen that there have been quite a few more storms, not all atmospheric rivers. Some some cutoff flows too that have been coming in. And overall, the region is now, much of the region is near normal above normal precipitation, with the exception of a lot of this year. It's much better than it was, but it's still, about 70 to 90% of normal. And we can see this here at looking at the snowpack, how much better it is now than it was at the beginning of February, with near 90, 95, and over 100% for the major watersheds in this year is in California. In Nevada, similarly, it was a pretty slow start. This yellow shading is a lower percentile. The green is kind of the median percentile, and you can see this relatively low start. So this is at Mount Rose, which is near Tahoe. It's a ski area. And then kind of this jump up at the beginning of March and getting pretty close to normal. So it's 88% currently of median peaks. This is snow water equivalent, or SWE. And then at Lee Canyon area, which is farther south, there was a big event in early February that really jumped up the SWE, and it's kind of remained above normal. So it's about 120% of normal SWE. And here's just a bit bigger picture throughout the California, Nevada region from the Natural Resource Conservation Service, where you can see the major watersheds. And you can see in both regions in Northern California and Northern Nevada, and also, I would say large parts of Nevada, above normal snow water equivalent. And then, within the Sierras, near normal. So some places a little bit above, one place a little bit below, but pretty close to normal in that region. Quickly looking at temperature. So this is from the Climate Toolbox, and this is from October through February. And this is maximum daily temperature, so how warm it is kind of the warmest part of the day. And this is nighttime temperature, minimum daily temperature, so how cold it is or the temperature at the coldest part of the day. And what you're seeing is that, for the maximum daily temperature, it's relatively close to normal, about 1 to 2 degrees above normal for large regions throughout California and Nevada. Some places are a little bit below, especially in the Southern California area. Oops, I'm gonna head too fast, sorry about that. And then in the minimum daily temperatures is actually where we're seeing warmer temperatures, so it's not dropping off or getting quite as cool at night. And so large, between 1 and 6 degrees, large parts of the region, that cold temperature at night is warmer this year than it is in the climatological mean. This last month, however, the last 30 days in particular have been much cooler. We're seeing about, between 1 to 3 degrees cooler throughout much of the region. The Central Valley is a bit of an exception in some places along the coast. The nighttime temperatures are still much warmer, some between 2 and 3 degrees warmer throughout, but you see more blue indicating some more cooler regions throughout this last month than what we did in the previous map. So what does this all mean for our reservoirs and our snowpack? And so this is the image that Mike Dettinger puts together, and I put the link here. And so it's for the Western Sierras. So quite a few of the different major reservoirs and even smaller reservoirs along the Western Sierra. And it's looking at that total storage. Because last year was such a wet year, we came in with above normal in that storage. And then you can see the snowpack, it was kind of inching along, and then it really started to pick up in February and March. And now, if you combine these two, slightly above normal for this time of year. This is looking at Lake Tahoe. Lake Tahoe started the water year well above normal, and because of that massive snowpack and all the precipitation last year. And you can see that the snowpack, similarly has really inched up in the last month or so. And so between the two is much above normal for the combined for this time of year. Oh, this didn't turn, sorry. You can actually go to the website here, but this is looking at soil moisture. I apologize, it was so blurry. It looked better on my screen. But this is looking at soil moisture throughout California and Nevada. And you can see it's in kind of these wetter percentiles between 80th to 90%, even some of them 100. throughout much of the regions. There's some of those areas in the corners that we were talking about in the drought monitor where it's a bit drier, and then also in northwestern Nevada as well. And I also want to touch on, this is looking at stream flow using USGS sites, and this is just the anomaly based on, it was yesterday, right? So how does it compare to yesterday? But you know, it's pretty close to, most of them are kind of in this normal or slightly above normal range. There are a couple again in the southeastern part of California and the southern part of Nevada that are below, but overall it's getting pretty close to normal. The last thing I wanted to touch on is the Colorado. So this is looking at the upper Colorado, the snowpack and precipitation has been about 100%, 110% of normal thus far this year. And Utah is about 105. And so this is just the status of, you know, where Lake Powell is. It's about 2.45 million acre feet more than last year, whereas Lake Mead is about 2.26 million acre feet, and you know, it's kind of right at that level 1 shortage level. But what we see here is kind of the seasonal uptick from all that snowmelt coming a bit later in the year. Another thing I wanted to highlight is from the Colorado Basin River Forecast Center. They do an estimate of probable inflows. And so here's this range. The minimal is 3.5 million acre feet, and the max probable is 7.9 acre feet. And the current forecast is about 5 million acre feet. So it's slightly below that historical average. And so that's where the forecast is. Well, I clicked ahead a little too soon, but I can talk about the summary. You know, for as variable as I think maybe one of the main things to take home from this, for as variable as a climate that both California and Nevada have, we're really pretty close to kind of a normal year, as normal as it comes for our region. But this was after a pretty slow start to the water year. Most of the precipitation came at the end of January through now. It is still the minimum. It's been, at least for minimum temperatures, were a bit warmer. The March has been a bit cooler. When we talk about reservoirs and snowpack, the storage throughout much of the state in California is kind of at or near normal levels. Lake Tahoe is well above normal levels. Soil moisture is, you know, on the wetter side. Stream flows are near normal, and the Colorado River Basin is near normal. I have to admit, for as many years as I've been looking at California and Nevada climate, I don't think I've been able to say normal so many times. It's pretty anomalous to have a year that is so close to normal, but that's really what this year is looking like it's going to shape up to be. So with that, I will stop there. And I can turn it, I didn't see any questions in the chat. Please, I forgot to mention this, but please feel free to put your questions into the question box and I will be monitoring them. I'm going to go ahead and turn it over to Nathan from the California Nevada River Forecast Center. Thanks. Oops.
All right, can you hear me and can you see my presentation?
I am seeing Patty's presentation. Oh, there we go. Perfect. Great. Yes.
All right. Can you see my cursor too? Just so that I know if I'm using the cursor, you can see it.
Yes, we can.
All right, thank you. All right, so the background image shown here is the true color imagery from the Terra Modis satellite depicted on March 19th, 2024. Shown here is a relatively healthy snowpack, as Julie alluded to, across much of the mountain ranges in California and Nevada. Couple things to point out here near Bakersfield, California, we have some convective clouds, and then there was a low pressure system along the Arizona border last week, and so this is actually cloud cover as opposed to precipitation. But elsewhere, there hasn't been very many clear sky days all winter where we actually have been able to see the snowpack throughout the whole region. So this is actually one of the clear images that I've been able to find. So that dry and clear stretch that we just had was really helpful to grab this image. Today I'm going to present the CNRC's outlook for both the April through July seasonal water supply, while also briefly covering the Climate Prediction Center's seasonal outlooks. All right. As of the March 2024 issuance, El Nino is rapidly decaying. Neutral conditions are favored for late spring, followed by an increasing probability of La Niña being established for summer and fall. The Climate Prediction Center has currently issued a La Niña watch. Looking at the CPC seasonal outlook for temperatures, the April through June outlook suggests above normal temperatures across much of the region with increasing probabilities as you head north. More saturated colors do not indicate varying levels of magnitude, so darker oranges don't indicate much warmer, but merely the probability increases. Reviewing last year's outlook for the same time period, most of the area was favoring normal temperatures, with portions of northern Nevada below normal. What occurred was a relatively cool May and June, which was really beneficial for managing last year's snowpack. Last year's snowpack also allowed for areas in the mountains and vegetation to stay wetter longer and helped limit last year's fire season. Looking at this year's map, the above normal temperatures, if they materialize, would help dry out vegetation quicker and perhaps contribute to increased fuels for fire season. Looking at precipitation, near normal precipitation is favored for this time period. From a climate perspective, things get drier from now through summer, so no surprises there. Somewhat counterintuitively, springtime precipitation falling as rain can sometimes be a negative. First, it can melt snowpack more quickly with warm, humid storms in the mountains, which of course isn't desirable, particularly when our reservoirs are nearly full as they are this year. The preference would be for the snowpack to act as a natural reservoir and melt slowly during summer. Second, substantial precipitation can increase smaller vegetation growth, which will then later dry out and produce additional fuel for fires, perhaps later in summer or fall. Drought can be measured in a variety of ways, the most common being precipitation and soil moisture, which drought.gov and the CPC outlooks focus on. Based on these criteria for the California-Nevada domain, no drought is predicted except for some small pockets near Las Vegas and then northeast of Klamath Falls in southern Oregon. One important thing to remind about is aquifer drawdown without recharge, and this isn't typically accounted for in these outlooks. So coming out of that 3-year drought that we had, missing precipitation can still have impacts on long-term water supply. All right, looking at SWE, on the left is a depiction of what snow water equivalent looked like last year, according to NORISC at roughly the same time. On the right is this year's SWE, which closely matches the satellite image I shared on the title slide. Here at the CNRC, we don't use the NORISC data directly, but it is one source we use to modify or adjust our modeled snowpack. It's quite striking how much more expansive the snowpack was last year, with a lot more lower elevation snow compared to this year. In order for the CNRC to produce stream flow forecasts and water supply projections, we need to use a variety of inputs. One of those is precipitation. On the left-hand side is the quality control grid that we produce internally each day, summed up from the start of the water year on October 1st and compared to normal through Friday. This would be the precipitation input we use to keep track of our soil states and the building of our snowpack volume. On the right is a similar depiction, but shows the mean aerial average for the Huck 8 basin units, which would then get broken down and further into the basins that we explicitly model. And I wanted to show this because I will be showing some of our water supply outlooks and just showing you what are the exact precipitation inputs that we are using to make those predictions. Portions of coastal California, Southern California, and upper portions of the Humboldt River system near Elko are shaded in darker greens to blues, indicating above normal precipitation since the start of October. Elsewhere, location with yellows and oranges generally indicate about 80 to 100% of normal precipitation. If you remember the really dry start that Julie mentioned to the water year all the way until the end of December and even through January. So the wet winter since hasn't allowed all areas to completely recover respect to the water year precipitation. Another look at SWE on the left is looking at CNRC modeled SWE. Things are generally near normal with some locations above normal. So precipitation, particularly in February, allowed many areas to recover from the dry start to the water year in terms of snowpack. On the right image, prior to our current weather over the weekend, the recent warm up and clear skies that we had in the middle portion of March allowed for a slight drop in our modeled SWE. Another look at SWE using DWR index products for the Sierras. Friday, different traces correspond to different years and moving left to right through the snowpack accumulation and melt season. The average annual progression is indicated by this lighter cyan color. The current year is represented by the blue line with the numbers. And for the Northern Sierra, in the top plot, the SWE is 109% of the April 1st average. The middle plot of the Central Sierra is 93%. And then the bottom plot is showing 87%. In all three plots, you can see the slight downtick in the blue curves representing the loss of SWE in the middle portions of March. We may have made some of this back up over the last day or two with the precipitation that came through. In addition to providing river forecasts at official forecast locations, the CNRC provides probabilistic forecasts at many more locations. Products include water supply forecasts that can help inform out to 365 days based on near-term weather forecasts as well as climatology. I don't have time to go through all of these individual locations, but you can actually access them by going to our website, Rivers, Reservoirs, and clicking the ensemble points, and then you can actually click on any of these locations and get a more accurate forecast for what you might be interested. I'm going to cover these two blue dots as just today. And just as a quick reminder, we know that we've had a change in our ISP provider. And so if you're having problems accessing our website, please make sure that you include the www in front of the CNRC. All right, so starting with the Sacramento Valley Water Supply Index, which was that top blue dot that I showed, this trend image shows the ensemble-based River Forecast Center's unimpaired flow forecast for April through July on the Sacramento River system, which includes the Shasta, Feather, Yuba, and American systems. So you can think of this as the expected natural flow as if there was no human modification of the waterways. The CNRC forecast incorporates current conditions, current weather, and then climatology as inputs. It does not incorporate hydrologic uncertainty. As of Friday, our median forecast, which would be right here, indicates 6.2 million acre feet, which is 134% of the 1980 to 2022 median. The different color banding that you see here, it indicates probabilities of exceeding a certain volume. So the most likely scenario would be represented by the purple shading. The black line corresponds to the forecasted median volume on any given day since the start of the water year. At the start of the water year in October, the color bands are wider due to additional weather uncertainty. As we enter spring, since most of our precipitation occurs during the winter wet season, the color bands begin to shrink in size. The black line experienced upticks during February due to it being wet, followed by a sharp decrease at the start of March due to the large stretch of drier and warmer weather we just experienced. And then we have the recent uptick here, which is in the last week, is that weather forecasts have trended a little bit cooler and wetter as we head towards April next week. This bar chart provides a seasonal to April-July flow for various years along the Sacramento River system. As you can see, boom and bust years and interannual variability can be expected, and this year's forecast is shown by the red bar in comparison to previous years. This plot shows total unimpaired flow on the Sacramento River system over a 5-year period covering water years 2020 through 2024. The pink portions representing observed flow accumulated over the last 4 years, with this year's water year forecast shown by the colored dots on the right. Each black vertical line that you see here is separating the different water years. And if you were basically to, and then the blue curve that we see here is what the expected accumulative volume would be for each year as we move through time. If we were to add up this year's water year forecast flow with the previous 4 years, the aggregated 5-year flow is 79% of the 5-year mean. So yes, having an average or above normal year helps, but the Northern California region is still running at a deficit when comparing volume across 5 years. In a sense, the loss of 21% indicates a loss of a full year's worth of volume. Looking at the San Joaquin as of Friday, here's a similar seasonal trend forecast for the San Joaquin system. The CNRC forecast is 3.7 million acre feet for the April through July time period, or 126% of the 1980 to 2022 median. The overall forecast pattern, as indicated by the black trend line, or I guess it's kind of a purple trend line here, is similar to what was shown for the Sacramento River system, reflecting the dry start to the water year, followed by a wet February here, the dip in March, and then the rise here at the end of March. To put this in perspective, last year's San Joaquin unimpaired runoff was about 8.5 million acre feet. So last year's observed flow was about two and a half times higher than what is forecasted for this year. Here is San Joaquin's April through July historical flow comparison with this year's forecast shown by the red bar. Last year's April through July volume was just a bit below the 1983 maximum. And similar to the Sacramento system, adding up the San Joaquin water supply index for this water year's forecasted flow with the previous 4 years, the aggregated 5-year flow is 93% of the 5-year mean. So the San Joaquin system has recovered a bit more from the previous 3-year drought compared to the Sacramento system. It is important to keep in mind the scale difference between the Sacramento and the San Joaquin systems, with the Sacramento system having nearly 3 times the volume expected. All right, depicted here are unimpaired runoff forecasts for the water year on the left and the April through July seasonal runoff on the right. Greenish to bluish colors are indicating near normal to above normal flow is predicted for large portions of the region. In the Sierra, the April through July percentages are slightly higher than they are for the water year. This is a result of the dry fall, even though base flow heading into winter was elevated. In Nevada, CNRC's modeling of the snowpack along the Humboldt predicts runoff volumes in the 140% of normal range. Here are the forecasted peak flow date forecasts for this year. These can change depending on how springtime temperatures respond, and in particular nighttime temperatures, because we get the melt during the day with the input from the solar radiation. However, if things cool off at night, it can kind of slow down and shut off the melt. But if we get any extended periods of warmer nighttime temperatures, we certainly can melt things a little bit quicker. And also, if you recall from earlier, the CPC April through the June outlook is favoring warmer than normal temperatures across the northern half of the Nevada or California region. And so CNRC modeling, which is used to produce these dates, uses past climatology into the future. So if warmer than normal temperatures occur, we can expect that these peak flow dates may actually occur slightly earlier than what is shown here. And then the last slide that I wanted to show was basically just the 2024 U.S. spring flood outlook. Heading into spring, no widespread flooding is expected for our region. For the Humboldt River system, based on the healthy snowpacks in northern and northeast Nevada, some minor localized and nuisance flooding may occur. And with that, I will stop sharing, I guess.
Great, thanks so much, Nathan. Very cool of the peak snow anticipated, or peak runoff. I hadn't seen that image before. That's very cool. We do have a question from you in the chat from Susan Wood. And it says, of California's water volume, note that it runs 79% of mean. So
that's for the 5-year period. So for the Sacramento system, which you can think of accumulating or aggregating water all the way down from Shasta down through Sacramento and the American River system, if you were to look at what would be expected over a 5-year time period, we're only, even with our forecast for this year, we would still only get about 79% of what we would normally see over that typical 5-year period.
Got it. Okay, great. Thank you for clarifying. That makes sense. I'm going to turn it over to Leslie Roach, a professor for the cooperative in rangeland management at UC Davis and part of UC Cooperative Extension, who will be talking about California rangelands conditions for this year. Thank you, Leslie.
Thank you. And you can see my screen all right?
Yep, it looks good.
Okay, great. Well, good morning, everyone. So I'm going to give a bit of a brief update on how this year's precipitation has impacted rangeland forage conditions in California and how kind of what the outlook is moving forward. So just give a little bit of California context. So rangelands are incredibly biologically diverse. You can think of them as the wildlands all around us, ranging from arid deserts and shrublands to more mesic grasslands and woodlands and even forested landscapes. And these span a range of climate zones from desert, semi-arid to Mediterranean climates. There's about 57 million acres of rangeland in California. That's a little bit over half of the state. And about 34 million of that is grazed by livestock. So in California, this diversity supports what we call transhumant ranching, where livestock are moved between pasture-based forage resources in a seasonal cycle. So typically they move from the lowlands, so our valleys and foothills in the winter, to the highlands, so mountain meadows, perennial grasslands, acre to pasture in the summer. And majority of the base ranches for these operations are in these valley foothills and grasslands. So focusing on California rangelands, because we are in a critical time period for those systems right now. They are mostly privately owned. They are a major forage base, producing over 70% of the state's livestock forage base. And so they're a key linchpin in California's yearly grazing calendar, and therefore they provide a critical economic foundation. They're also one of the world's major biodiversity hotspots. California's annual rangelands, which include grasslands, savannas, and woodlands, cover about 15 million acres and host a really broad diversity of species. And so they have great economic, social, and ecological value. Annual rangeland can be particularly challenging. Rangeland forage production, its productivity is extremely variable, really in part because the plant community phenology or the timing of the life cycle events of the plants, they really are dynamically linked to seasonal weather patterns. And a key challenge is that optimum temperature and moisture conditions for plant growth are out of sync with each other in this Mediterranean system. So if all goes well in a typical or normal year, as we heard is a bit anomalous for us recently, the annual rangeland growing season is initialized with fall rain, so somewhere in this period between September and December. As we move into winter, so December through February, plant growth slows due to those lower air temperatures, lower solar radiation. But as we move into late winter, early spring, kind of where we are now is where we see kind of this surge here of rapid growth beginning as temperatures increase and solar radiation intensifies. And then about mid to late spring, after this rapid growth stage, plant production reaches peak biomass once that root zone moisture is depleted. And so of course, and then growth rates decline and we enter what we call our summer dormant period. The result is that we can get extremely high spatial temporal variability in forage productivity, both due to that characteristic climatic as well as biophysical diversity across our rangelands, as well as how the plant's life cycle are so dynamically linked to the climatic drivers. So forage production can vary by as much as 4 times or even greater, both interannually at a given location and within a given year at different locations. And this is just an example from San Luis Obispo County, where we have a coastal site and an inland site in wet years versus dry years. You can see the immense amount of differences you can see within a single site between different years, as well as across sites within the same county within a given year. This variability is further increasing as climate changes, and we're seeing increasingly large year-to-year fluctuations and instability of the forage supply. And so a little bit of work that some colleagues and I did recently looking at long-term annual rangeland productivity, we did indeed find it is highly variable. This just kind of shows you that variability over a 14-year period as it cycles through. We found a number of factors to drive this variability in long-term forage production, namely the total amount of precipitation and the timing or distribution of that precipitation. We found were dominant drivers of production. Specifically November, so when we have the start of the growing season, that germination period, and April, where we had that rapid, that curve really took off and we had rapid growth. These precipitation during these times are particularly strong influencers of forage production. And of course, the importance of these drivers vary by region. We've actually found quite a few different features or drivers of forage production. This just shows some of those features by region. Just kind of in general, we found that precipitation, so the amount, but also the timing, plays a more important role in drier areas like the Central Coast and Sierra Nevada foothills, where energy and temperature, something about solar radiation, play larger roles in wetter areas such as North Coast ranges. And we're seeing some of that play out this year already. So in terms of updates, so where are we for rangeland conditions? Just kind of remind you, and we talked heard a little bit about this a few minutes ago, where we last 2 years, we're slowly coming, seeing these drought conditions lessening a little bit each year. And where we are right now, of course, we're in much better shape at this point in time. And so I'm just going to take a quick tour across California to give you a snapshot of current conditions as they're being reported from our colleagues in cooperative extension across the state. So we'll start with northern or northeastern California. So Lassen, Plumas, Sierra, Siskiyou, and Modoc counties. In general, it is still very early in the season for them, but we're getting reports that generally in good shape across the region and looking forward to the coming progression of the season. One rancher in Siskiyou County reported that green up is great. Our reservoir is filled. It's looking great. Good snowpack as well, as long as it doesn't come off too quickly. And we're not done yet. We have a week of rain coming as well as snow. There were some reports of local concerns about some warmer than usual winter, as well as some pockets of mountain ground that have less moisture or forage production than they've had in what they consider more normal years. Moving over to the North Coast, it's been a warm, wet winter in Humboldt and Del Norte counties. Growing degree days and soil temperatures have been suitable for grass growth for almost the entire winter season. Although there's some variation in local conditions. So higher up in the hill ranches, forage growth has been average to above average since for the whole season, since about October. However, in the lower pasture lands, soils are super saturated, and so that's really limiting access for livestock to graze those areas. And so really the biggest hurdle for this area has been a pretty wet season. One Humboldt County rancher said that they haven't had 3 dry days in a row since October. So moving across the valley over to the Sierra foothills, we've had reports of a normal precipitation year, as we just heard earlier. However, there's been some forage growth that's been below average in some areas. One of our long-term monitoring sites for University of California has reported about 600 pounds of forage per acre on March 1, and their long-term average is about 750. So they are kind of picking up on that below average forage growth. And so, as I mentioned earlier, growing grass is complicated. It's not just about, the water year total, but the timing, the distribution of precipitation, soil and air temperature, solar radiation. So it might be, why we have a little bit of a mismatch here. But right now they have good soil moisture conditions and warmer temperatures, with some upcoming potentially well-timed rains. Recall I said that April was also a really important time of year for these systems. And so they're entered the rapid growth phase, and if things continue to clip along, it should be a good year. So moving back to the valley, so Sacramento and San Joaquin Valley, it's been much better conditions than the past 2 years, especially in the North Valley, as we just heard, in the Tehama and Glenclusa area. We had reports of, reservoirs are full, lakes look good, creeks are flowing. We've had higher than average forage production reported in some areas. And as the South Valley cooperator said, we're pretty average, which is pretty good. And then lastly, going to wrap up with the Central Coast area. We've had reports of variable local conditions near the coast. So kind of this picture here is a little closer to the coastal side of San Luis Obispo and Monterey counties. Things are okay and doing quite well. However, further inland, which is this photo down here, we've seen that forage has not grown much, even though average rainfall is a bit above average. This is that time of season where the grass should be taking off, but it's already heading out. So the grass is already setting seed, which is signaling the end of that growth period. And it appears the grass is pretty stressed right now from getting a dry down so quickly. And so unless they get some more rain soon, it could be a lower than average forage production year, but it looks like maybe there's some more rainfall predicted in the coming week, which might help significantly. So overall rangeland conditions are faring better than they were last year, with lots of folks looking forward to the coming rains. I just want to quickly acknowledge all of the contributors, from Siskiyou County all the way down to Kern County that contributed to this report. And just want to close, with rangelands and ranching. We're always thinking about drought is always looming, and so it's not time to forget about the drought. We still need to be thinking about proactively planning for forage conditions. All right, thank you.
Great. Thank you so much, Leslie. Appreciate it. I'm going to turn it over to Patty now to talk about Nevada.
Okay, can you see my screen?
Yep, it looks great.
Okay, great. All right, so you saw nice green pictures of California, but this is Nevada. And this was taken during an aerial census flight by Bruce Thompson. It's our wild horse and burro specialist from Elko District. And this is actually Lake Winnemucca, which is east of Pyramid Lake, northeast of Reno. So completely full of water this year.
Did we lose Patty?
Oh, we lost Patty, I think. Let's give her a second to see if she's able to join again. I do have her presentation, but I wouldn't be one that'd be very good at sharing it. Let's give her just a minute.
Well, we can take some questions in the meantime while she gets back on. I do think she might have accidentally closed out of the window trying to get to the next slide. So if you have any questions, go ahead and send them to us in the question box, and we'll address some of those and see if we can get Patty back up.
That sounds great. Thanks, Eleanor. Nathan, you answered the question about the total water volume, but Susan came back with what was the number. I don't know it might be easier for you to answer her directly in the questions if you see it, Nathan. But if anybody else has any other questions, we are definitely happy to answer them.
We do have Patty back now.
Oh,
so
okay.
Sorry. Totally okay.
Worries.
Let me give you the screen share and then we can kick back off.
It would not advance, so it's not giving the screen share. Here we go. Can you see it now?
Yep, it's not in presenter mode, but we see it.
Yeah, it may not advance, Julie. You might want to do this. Let me try it again.
Okay.
Okay, there we go.
Okay, great.
Can
Perfect.
you see it now? Sorry.
Don't worry,
completely
you're good.
kicked me out. So anyway, so I just wanted to bring out the importance of the rangelands. Unlike California, they are mostly federally owned in Nevada. And those rangelands support our beef, cow-calf, and sheep-lamb operations, as also providing hay. We do wild hay, meadow hay, and corn, and those provide aftermath grazing for the range and livestock. And being a dairy farmer's daughter, I had to mention we do have some dairies in Nevada. So unlike California, we sit in the continent. It's a continental climate. We have different elevations where we are with our latitudes. Most of our precip occurs during the fall, winter, and spring months. We sit on the east side of the Sierras, so it's a big barrier to the moisture and the maritime winds. As an example, we did have a storm this weekend, and the summit did get some snow, about 12 inches of snow, but I live east of Carson City and I had 3 feet of wind, so no moisture for me. The Rocky Mountains also block moisture from the Gulf of Mexico, but we do get some monsoonal moisture coming from the North American monsoon, usually summer convection storms in the late summer. So we have 4 well-defined seasons and a very dry system. So we are the driest state in the nation with about an average of 10 inches of rain. But you can see that we're expecting much more precip. April, May, and June are some big months. Southern Nevada actually gets a substantial amount of moisture in July, August, and September from those convection storms. So just looking at our plant growth factors where we're at. So departure from normal precip, we are above normal in the northern part of the state and some scattered areas around southern Nevada. Our precip has been much warmer than normal, however. And you saw Nathan's pictures of the snow water equivalent. This one on the left was right after the big storm that brought an increase of about 30% of our snowpack in the Sierras. So we had good snow across northern Nevada, and I ran this snow water equivalent this morning. So that snow we had over the weekend still were right around normal for our western basins here. So I pulled some stuff off the climate engine, our long-term drought blend and our short-term drought blends. And so you can see that actually our long-term drought blend, a year ago, we were 6.5% of the state was from D0 to D4. So we're less than that. So we're actually in normal to above normal conditions. It looks like throughout the state, even southern Nevada was showing as part of the drought monitor, but the short-term drought blend is showing it's near normal. Our Palmer Drought Severity Index, this is a comparison of February of 2023 and 2024. We certainly were much wetter in 2023, although the southern end of Nevada was still very dry. Some of those conditions have been alleviated, though, through the winter and thanks to Hurricane Hillary last August. So our drought response index, again, a comparison of 2023 and 2024. As Julie said, those cooler temperatures, we don't have as much growth showing up just yet. It's still early spring and out of season for most of Nevada. So if you look a little closer, here's some of our temperature and precip. So much warmer temperatures in eastern and central Nevada. Our percent normal is precip is above, but we are below normal on our snow pack, so our snowfall. So what's happened is we received a lot of precip, but it was in the form of rain and not snow. Here's some more aerial flights comparing 2023 and 2024. This is in eastern Nevada. And another one, we had a good snowpack. This is a little farther south of the last ones, and not quite the snowpack that we had in Spring Valley last year. So again, we are in early spring. Our plant growth curves, you can see they peak a little later. Those are based on elevation. So our higher ones are aspen stands. Don't peak until late July, early August. And then our main forage grasses, the Colombian needlegrass, Letterman's needlegrass, those are higher elevation grasses. Our Sandberg's bluegrass at the very bottom does start growth in early March, late February, and it is starting to green up. That provides early forage at the beginning of the growing season here. And so we are seeing green up in the valley floors at 4 to 8 inch precip zone, and we've got some of our shrubs starting to green up and some of our grasses. So this is just an example of Hurricane Hillary that came through in August. We did get some green up in Las Vegas, and they actually had almost 3 inches of precip last fall and late summer. And so the desert really will respond quickly, and we can get a nice flower display. So in summary, it looks like we have good moisture across the state. I think our growth yield equations looks like we're going to be normal if we continue to get precip in April, May, and June. And we are seeing some green up on the valleys and the lower slopes. So sorry, I may have delayed us a little bit. So, okay, thank you.
Thank you so much, Patty. And timing-wise, we've actually done pretty well. I wanted to open it up to see if there one last time for any questions to put into either the questions or the chat. But otherwise, so maybe give it a moment while we wait for those to come in if there are any last questions. And if not, I think we can go ahead and wrap up and hope you guys will all, sorry, I forgot to mention that this will be posted on YouTube and there will be a webinar summary that is posted as well on the NIMS site. So thank you all for joining today and very much thank our presenters. We couldn't do this without you, so very much appreciate you taking the time to put together the presentations and present on the webinar. So thanks and have a great week, everyone.